Alright, so this is a strange sort of video, but something that's been kicking around in my brain for a little while. So this started a few weeks ago with a dream I had. I was at a spy convention, and there were all these puzzles in place that people were trying to crack, and one of them involved using the right combination of little coffee dispensing cups in a machine that would open a back door and let you do something. I got intrigued by this puzzle where this woman was looking at a piece of plastic with 5 bolts through it, and there was information encoded into that object. And I woke up wondering how the information was encoded, and I had an idea. And the idea was to basically code information using 3 grains of sand. And so here was the proposal I had. So here's our first grain. I'm going to draw it not as a point, but as a big uh, object so we can see it. So here's the second grain. Here's the third grain. And I'm just doing these in a line. And the question is there information that we can deliberately store in the positioning of these? Now I'm going to make 2 bold assumptions. The first assumption is that space is not quantized. In other words, if we put this out on a number line, like so, I'm going to assume that we can position something, right, at any point that we want in here precisely. And I'm also going to assume that we can measure the position of something with arbitrary precision. Now, the position of something like a grain of sand needs to be defined because, of course, a grain of sand has dimensions to it. So are we talking about, the leftmost edge or the middle of it? And where does the grain of sand actually begin? And do we count, the orbit of the electron? And, of course, we know electrons aren't fixed in their position in space. They exist in a location defined by a probability function and so on. But ignoring all of that, right, let's just take a very simplistic view. And let's suppose that I can position, these things and measure their position with absolute precision. So here's what I'm going to do. I'm going to code information as follows. I'm going to put 1 grain of sand at one point, a second at another point, and I'm going to draw a number line. And I'm going to put 0 where that first grain is, and 1 where that second grain is. And now, this third grain of sand, if I measure its position relative to the first, this encodes a real number, right? And the distance from, this grain to that grain gives me my basis of measurement, a unit length. And so if I know that, this grain is exactly twice the distance as that one from my marker, right, then I've coded the number 2. And if it's the same distance, it's 1. And if I put it over here, it might be the number, 0.2718. So basically, this is a way to encode a real number. And then the question is, what kind of information can we encode in a single real number? Well, we can encode, the time of day, the number of seconds since midnight. We can encode the date by taking, the number of nanoseconds since January 1st, 1970, right? And things like that. We can also code, plain old information like, a character. So we can take the ASCII code for a character, and that's a number from 0 through 127. And so, if we put this at position 1, that's the number, 1, so that's character A, control A. If we put it at 65, that's character 65 is the letter A, and so on. But we don't have to go out to 127, right? We could do all of this coding simply by putting our third grain of sand somewhere between 0 and 1, because in fact, in the real interval from 0 to 1, we can code essentially an infinite amount of information, right? And how do we do that? Because any number in here has an infinite string of digits. Well, suppose we had a message, right, like ABC. What we can do is we can code out, just the decimal ASCII code for these 3 characters. So I'll put a 0 in the front because some are 3 digits. So 065, 066, 067. And suppose I just store my information by putting a grain of sand at exactly this location, right? So I can store my ASCII string. And if I want to know what my secret message is, I just see where that grain of sand is located. I measure it precisely, right? and I see it's at location 0.065066067, and I translate these into, my 3 characters. All right, so that's a potentially interesting thing to think about, because we're not limited to ASCII characters. We could store an image by taking a JPEG and writing it out in binary, and just make a binary number started with a 0, and we get a number between 0 and 1. We could do movies, of course, because we could do a sequence of images, and you could go to Google's server and assuming they have one server, take all the information that's stored in there, order it, in some well-ordered way, and store in a single real number the entire contents of everything in Google's search library. So I mean, so this is this is what I was dreaming about basically, and woke up and played around with it a little. So I was talking to Karina, fiance, about this, and she had 2 interesting insights. So we started thinking about this, and her first question was, could you have multiple grains of sand that describe each other's position? So the idea was, code the position of every particle in the universe, assuming that's finite, right? Lots of crazy simplification going on here, but order your particles, and for each particle record its position, its mass, its velocity, its acceleration, its higher order derivatives of motion, its spin, its charm, all this other stuff that I don't understand. But could you encode, all of the information about the current state of the universe in the position of a single grain of sand, basically? So her follow-on was, could you have particles that encode that information about each other? And so we started playing with that with number sequences. And her second observation was that for her it's easier to work with letters than with numbers, and it turns out to be easier to see patterns like that. So we started playing with sequences of letters, and so I'm going to make 2 sequences. The first I'm going to call sequence A, and the second sequence B. And A is going to begin with the letter A, and B is going to begin with the letter B. Not very inspired, but it's a starting point. And what I want is A to encode information not just about itself, but about the letter B, the string B also. So here's what I'm going to do. I'm going to interleave 2 pieces of information in this A string. So I'm going to store in every other position information about sequence A. And in the positions in between those, I'm going to store information about sequence B. And sequence B is going to do the same thing, except it's going to begin with information about sequence B, and then in between those characters, I'm going to store information about sequence A. All right, so A begins with the letter A. We've got that information coded. What's the next character of A? It should be the first character of letter B, sequence B. All right, and let me label these. So this will be A0, A1, A2, A3, A4. This will be B0, B1, B2, B3, and B4. And for the B string, this first character will be B0, B1, B2, B3, B4, and the intermediate characters will be A0, A1, A2, A3, A4. All right, so the first character of A0 is an A. First character of B is B0, that's a B. Okay, we now have enough information to fill in this next character for the A string, which should be B0, the first character of B, that's the letter B. And now we can fill in the second character for the B string, that should be A0, the first character of the A string, that's the letter A. And now we're off and running. So next we should store the second character of A, which is of course a B, and then the second character of B, which is an A. And then we should store the third character, A2 of A, while A is ABB, so this should be a B. And then we should store the third character of B right here. Well, we need to generate some more of B first. So B starts off with a B, and then an A, and then it should be an A, and then it should be the second character of A, which is a B, and then it should be the third character of B, which is an A, and then the third character of A, which is a B, and then it should be the fourth character of B, which is a B, and the fourth character of A, which is an A. And then finally the fifth character of B, 1, 2, 3, 4, 5, is an A, and the fifth character of A is an ABBAB. And now we can fill in the rest of A and ABBAB, so we should have, so we've got A0, B0, A1, B1, A2. We should do the third character of B, which is an A. And then the fourth character of A, which is an A. Fourth character of B is a B. Fifth character of A, which is a B. And fifth character of B, which is an A. So there's our two strings so far. And not surprisingly, right, these are symmetric. If you change your A's to B's, you go from the A string to the B string. So we only really need to study one of these strings. And there's no obvious pattern in this. There's patterns that start to appear, but they break really quickly. And so, you know, how do we analyze this? Well, write some code. So here's a short C program that basically will generate two of these strings. So we'll generate an A string and a B string. A starts with AB, B starts with BA, right? That's just taken from our pattern here. And as we go through, we fill in two characters at a time, right? We fill in the next two output characters for A and B by grabbing, you know, the incoming characters from A and B, respectively. So a pair of indices, and then when we're done, we're just going to output these things. And this will output the A row and the B row, but we don't really need to output B. And you know, we can throw a pause in here. Right. And what I'm doing in here is I'm calling an output routine inside here. Instead of just printing the number, I'm calling output, and output will basically just print out either a space or a star. Okay, a space for an A and a star for a B. So this is another of Karina's embellishments on this. So let me make this really small. And here's the pattern that's coming out. And you know, it's a little hard to see exactly what's going on here, but if we pause this output, it's not an obvious pattern. I mean, there's symmetries here, and you can kind of look at, you know, where these gaps are, for example, these vertical lines, but in general, it looks like, you know, they occur in this row and then in this row, or this column, this column, this column. But when you start looking at them more closely, you don't see a repeating pattern. You see breaks in it, and so you know, that's potentially fun. So what I did was I put this stuff into a file, and you know, so here's the first string: ABBA, BAAB, ABBA, ABA, BABA, etc., 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 right? And this is alternating between the A string and the B string, so we just need to look at the first one. So how do we assess this? Well, let's look for patterns. Okay, so So there's a command I made called toFind, which will basically search this this string of A's and B's for particular patterns. So we can search the A string for, you know, the pattern AB. And here's all the positions in the string where it occurs. So 0, 3, 6, 10, 12, 15, 18, and so on. And I don't know an obvious pattern that corresponds to this sequence of numbers, right? I mean, they start off with, you know, 1 plus 2, 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4. Here's the fifth triangular number, but there's a 12 sitting in the middle. The difference of these, you know, there's a difference of 3, 3, 4, 2, 3, 3, 2, 4. And the difference feels like it's always 2, 3, or 4. But the sequence of those differences doesn't seem to lend itself to something very, very obvious. So, you know, we can graph this out. And it's an interesting graph because these points lie along, you know, what looks like a nice smooth line. But they're not evenly spaced, right? And so just kind of looking for patterns inside this distribution of these lines, right, the spacing between them. You know, there's a light and a dark and a light and a dark, but there's an extra dark band here, and here's some skinny dark bands, and there's something kind of weird going on here, right? So that by itself is kind of interesting. But then, you know, the next question is, what if we do 3 strings? So here's the 3-find version. And this one I deliberately seeded a little differently. So we're going to have basically 3 strings. So we'll think of them as A, B, and C. And each should code information about the others. So A is going to start with an A, B will start with a B, C will start with a C. But I did something deliberately unusual here, down here in these 3 lines of initialization. So A is going to refer to first information about string A, and then B, and then C. And so I'm reading down each column. So B is going to refer to the contents of string B, and then string A, and then string C. And then over here, third column, C is going to refer to C, and then A, and then B. So the order in which I'm coding this information about the strings is not symmetric, right? It's not ABC, BCA, CAB. I switched up this B string to also code A first. And then we do the same thing. We just go through and we build out these strings in such a way that, you know, every third character starting here describes the characters of the A sequence. Every third character starting here describes the characters of the B sequence, and every third character starting here describes the characters of the C sequence. And so we can do that, and we can run this sequence out. And if we do that, we get this. And so this file, you know, I wrote out as 3 lines. So, you know, the A string starts as ABC, B, AA, CC, BB, AAA, and so on and so forth. The B string starts BAC, BACC, and the C string starts CAB, AB, etc., etc. Right? And so we can play with those. So there's a 3-find, and we can, you know, search the A string for occurrences of the letter A, and we get this interesting sequence, 0, 4, 5, 10, 11, 12, 15. If we search the B string for occurrences of the letter B, we get 0, 4, 8, 10, 12, 14. And if we search the C string for occurrences of the letter C, we get a stranger looking sequence, 0, 7, 8, 19, 20, 21. So we've broken symmetry here, which is nice. That's fun to do. So you know, I wrote some code that would let us search for sequences, and I want to show you 3 particular sequences. So the first was searching for a CAB in the C string. All right. And this takes a little while because I didn't get very elegant with writing this out. Let me just do it like this. And that should not be taking that long. Oh, it's got to generate the whole thing first. All right, so there you go. CAB occurs only 7 times, right? It occurs at positions 0, 8, 80, 728, 65, 60, 59, 0, 48, and 531140. All right, and these turn out to be related to powers of 3, right? So this is 3 to the n minus 1, where n is even. So 0 is, 3 to the 0 minus 1. This is 3 squared minus 1. This is 3 to the 4th, and so on and so forth. So that's believable, right? And then if we search for, in the A string, search for the pattern CBA. This will also give us powers of 3, but it'll be 3 to the n minus 1 where n is odd. And that's also not too shocking. So we've got 226, 242, and so on, right? And that's 3 to the 1st minus 1, that's 3 cubed minus 1, that's 3 to the 5th minus 1. All right, so those we have patterns popping up, and we'd expect some patterns, but we find some breaks in those patterns also. So let me find you a general output that I did. So this was looking at the first 1,000,000 characters of each string, and searching the A string, number of times that a sequence occurs. So the number of times that the letter A occurs was 468,000. The letter B occurs 354,000 times. The letter C 177,000 times. Looking for the occurrence of two character strings, right? AB occurred, 4,084, BA 4,095, and no occurrences of CA. And this is interesting, right? This is almost the same, but not quite. A starts with the string ABC, and that only occurs once. B starts with the string BAC, that never occurs. C starts with CAB, that never occurs, right? And when you play this out with different strings, for example, in the B string, B starts with BAC. Well, that actually occurs twice. And the pattern that we find starting off the C string, CAB, that occurs 6 times. But yet ABC occurs no times. And then when we come down to the C string, ABC, which starts off string A, occurs 11 times. The start of string C, CAB, occurs 7 times, and BAC occurs no times. So different situations there, right? And if we go back to the A string and we look at all of the 2-character strings, you find some of these occur almost 500,000 times, and some of these occur occasionally, but not completely missing. And here's one that is completely missing. And the same thing happens with 3-character strings. So we have some strings that occur 11 times, or only 1 time, and we have some strings that occur no times. And this is fairly different from A to B. In the A string, we had some patterns like CA that never occurred. In the B string, all of our 2-character sequences occur, but CA is only 6 times, AC is only 12 times. And in the C string, right, we have one missing 2-character string and one infrequent one, and so on and so forth. So this is interesting data to look at, just looking at the number of times that that each pattern occurs. But if you actually look at where these strings occur, we can start, looking at some graphs. So here I plotted out just looking at the string BCB occurring in the main string A. So this is BCB sitting inside A. And I'm looking at the position where each of these occurs. So let's, so here's out 3. So BCB, for example, occurs right here. So I'm in VI, so I can search for BCB. It occurs at position 1. And it occurs again over here at position, I don't want to count those, but like something close to 20. And it occurs over here, and it's fairly common occurrence in this string. So what I've done is I've put these into a CSV file, and the occurrence of BCB, positions 1, 25, 73, 181, 217, and so on. All right, we can plot these out, and we get this interesting graph, right? That kind of moves along linearly and then suddenly jumps, right? There's a big gap. For example, right here, entry 22 was at position 2185, and then it's over 2,000 characters before BCB occurs again, all the way down to character 4393. And that's what these seemingly vertical lines are, right? An intriguing thing about this graph is there's some symmetry in here, right? There's this big jump in the middle, and then there's a sequence with a modest jump and another sequence, and over here on the left side there's a sequence with a modest jump and a sequence. And I don't think it's exact, but the structure seems very similar, and it also feels fractal, right? It feels like this little piece from here to here is mimicking what we see from here to there, right? With something with a little modest jump and then a bigger jump and then another modest jump, and inside one of these sequences we see a little tiny jump and then a bigger jump and then back to a small jump. So if we plot the difference between the positions of these occurrences, that's the second column, so 24, 48, 108, 36, and so on. And if we graph that, yeah, our symmetry kind of jumps out at us, right? Big point in the middle, and then even points over here on the side, and so on. And then if we plot the differences between those, we see more symmetry, right? In this case, positive and negative, but definitely something that looks reflective, around both axes in this case. And not quite linear, right? If we were to connect these outlying points, we'd get something, concave, like that. So I don't know what to make of any of this. I don't know if any of it is interesting. I don't know if any of these characteristics are actually unusual, or if it's, just big red herring somewhere. But that's just something I've been kicking around. And, as usual with these things, this is, one very thin branch of sort of exploration down what's a very wide area of questions one can ask. And the original question, was coding information in position of particles, but it's gone into this notion of strings that can collectively reference each other and store information about each other, which I would kind of expect would be a highly symmetric thing. But it turns out it's apparently not. And for comparison's sake, if we wanted to code just the information about string A and the string A, it's just a big long sequence of A's, right? And each A tells us what the next character of A is. Well, that's quintessential self-reference, right? I. And that's a totally clean solution. But once you get to 2 characters, it starts to get more interesting. So anyway, that's just something I've been kicking around for what it's worth. All right, thanks. Bye.